In an age where innovation and technology are advancing at an unprecedented rate, it's evident that the field of artificial intelligence stands out as the beacon of change. AI influences our daily lives, from the simplest tasks to the most complex undertakings, forging a future that we're walking into faster and faster that we could have only dreamed of through sci-fi novels in the past. So in the spirit of acknowledging the great shoulders that we stand on, I decided that it's time to invent a hypothetical Nobel Prize for Artificial Intelligence. Yeah, I'm calling it the Curious Future Award. And it's equally as prestigious as the Nobel Prize, it just doesn't come with all of that money, or any of that baggage associated with Alfred Nobel. So I have 5 nominees for the Nobel Prize in Artificial Intelligence called the Curious Future Award. This is the first nominee. Hieu Pham and colleagues for efficient neural architecture search. This ENAS system is incredible because it can actually sketch out a blueprint for all these different ways that you can actually construct a neural network. Like blueprints or a design, it can make many different hypothetical models and in a sense simulate how good they're going to be at learning and accomplishing a task. But here's the genius part. In an evolutionary sense, instead of starting over from zero, which each of the blueprints, it actually has a sense of evolution to it. It uses the power of AI to cleverly recycle bits and pieces of previous architectures. Learning what works and what doesn't over time allows it to increase performance and reduce redundancies. And Hieu's team put ENAS to the test. In the language realm, it quickly found a competing architecture that's better than the state of the art. And it did it in a fraction of the time it would have taken human architects to think about all these different models. And this ENAS breakthrough is a contender for this year's Curious Future Award, both because of its swift, efficient manner of trying new things and keeping the ones that matter, but also the intuition of the creators to think about how the human mind works, to acknowledge that we have one part of our brain, something that controls our heart rate and a lot of our body movements, but it's below the conscious thinking. In a sense, ENAS is thinking about how to think. It's thinking about the best model to actually take an input and solve a problem. And our second candidate is the most well-known scientist on this list, Geoffrey Hinton and colleagues, producing the paper called Dynamic Routing Between Capsules. So they came up with this brainy new concept called a capsule. Think of it as a box with all these tiny little mini brains inside of it. Now an analogy for each of these brains would be a neuron in our head or a perceptron if it was all digital. But what's interesting about these capsule brains is that they don't just have the ability to say yes or no. They're actually vectors, the arrows that you would see in mathematics. And depending on their orientation and depending on the length of the vectors, they can signal differently to the different little mini brains around them. But having all of these capsules together is like the neurons in our brain, but like the dendrites, you can actually change the strength of the connections, the direction of the connections. It makes it much more interesting when it comes to training a more complex model. And a normal neural network uses basically calculus to go back through what they call backpropagation and change all of the different weights. But length and orientation are something that can be calculated like a vector database with vector mathematics. The idea of capsules is really a fresh perspective in the world of machine intelligence. They're sturdier, they're more versatile, and they break away from some of the previous limitations. Our third candidate is Andrew Selbst and colleagues for a paper called Fairness and Abstraction in Socio-Technical Systems. The paper examines the challenge of applying computer science principles, such as abstraction and modular design, to ensure fairness across socio-technical systems. And when I'm saying socio-technical, imagine something like a social network that kind of is a technical product, but it influences our lives in real ways. And the research really honed in on these 5 basically traps that people fall into when using computational science to think about real-world people, socio-technical people. First one's called the framing trap, and that's when the creators of these kind of systems just spend all their time like engineers, speaking like engineers, thinking like engineers, but they're not thinking like humans, bigger systems that actually influence all of us. The portability trap, which is the assumption that if you create a solution for one environment, that it will hold in all the other environments that it eventually finds itself. The formalism trap, which is when you overlook the entire consequence of bringing a new technology like this into fruition, identifying how is this going to affect people's behaviors and values. And finally, the solution trap, which is the blind belief that technology is always the better answer for a problem. And the reason why this paper is in the running for the Curious Future Award is because I see this as alignment. This is the alignment problem. The framing trap or the ripple effect trap, the solutionism trap, this is so likely to be how we let AI get away from us. It's important to get this out there. It highlights the potential dangers of overlooking the social implications of all this stuff that we're building. Our fourth candidate is Baolin, Peng, and colleagues, from the paper called Towards Neural Network-Based Reasoning. So this is cool. These guys came up with an entirely new framework to build neural networks. But this framework, called the Neural Reasoner, is a step forward in explainable AI. It's specifically designed to reason and answer questions using multiple facts, sometimes logically putting them together first. This framework has this unique layered structure to how it looks inside. Instead of one giant latent space with all these things that you can just point to and not understand why, the same way ChatGPT would come up with its next word prediction, the Neural Reasoner has patches of logic that stick together, and those entire patches move around when it makes a prediction. So the first thing it does is it transforms different types of questions and facts into their vector form. Vector mathematics. And then they're essentially locked together as different layers of reason. So you can keep updating the vector representations, making the whole system smarter, but the logic stays intact. And the amazing part is that once you finally have the entire model trained, if you ask a question, you get an answer, just like today's tools. But if you actually want to peer into the system and say, how did you come to that conclusion? It has an answer for you, something that ChatGPT does not. Its ability to effectively deduce answers from given facts, and it is still learning. It's not just like we program in certain logic that it has to follow, but rather it looks to encapsulate reasoning, things that make sense, and stick them together for the long haul. And our fifth and final candidate is Jean-Bastien Grill and colleagues, from the paper Bootstrap Your Own Latent, a new approach to self-supervised learning, or BYOL for short. This is a new self-supervised learning algorithm, and it lets computers learn images without needing labels. Whoa. That's a big change. This is big news right now because there are so many people who are employed at these big companies to just label data for training. In fact, we're part of that story too. If you've ever filled out a CAPTCHA and it was like, where's the fire hydrant? Where's the crosswalk? All we're doing is training that system with a label. But current techniques need this. So there's thousands and thousands of people who work for Tesla that just look at video footage all day, identifying sidewalks and peoples and stoplights and all that stuff. But Bootstrap Your Own Latent, BYOL, might be a solution that can save all of that work. And the idea is to actually have two different neural networks that are connected and talking with one another. So you start with an image and it makes two variations, sends one down to both of the two brains. So one we call the online system, and it gets an image that's been slightly altered, and then it takes a guess as to what the original image was. Its job is to guess what the target system is seeing. Now the target system actually saw the original image, but it also takes into account the guess that came from the online system. But this guessing is how it gets closer and closer to self-identifying, the whole system self-identifying what objects are. So it doesn't necessarily need examples from humans to step in there and say this is wrong, this is right. It just needs this system to get better tuned over time at taking guesses and feeding that information to the other one. And one of the reasons why it's here for the Curious Future Award, the Nobel Prize of AI, is because it works, and it works really well right now. There's an image data labeling test called ImageNet, and it's killing it at that, with no need for wrong examples or labeled data. And to me, that feels like a really important step towards getting this kind of a system into a robot or a drone or something that can just learn in the environment as it goes along. All right, so you have our 5 candidates for this big Nobel Prize-esque award. So before I issue the Curious Future Award for the advancement of artificial intelligence, here is a recap of our 5 candidates. Hieu Pham for the efficient neural architecture search. Geoffrey Hinton for the dynamic routing between capsules. Andrew Selbst for fairness and abstraction in socio-technical systems. Baolin Peng for the paper Towards Neural Network-Based Reasoning. And Jean-Bastien Grill for Bootstrap Your Own Latent. And the winner is Baolin Peng, Towards Neural Network-Based Reasoning. Congratulations, it's an excellent paper. And this is the kind of thing that we desperately need to survive the singularity, to make sure that artificial intelligence integrates into our society successfully. We just can't ever have a system like ChatGPT making decisions about who should go to jail, whether or not to trigger a weapon, or even recommend somebody for us to go on a date with. We need some kind of explainability. You don't just want to say, I don't know why, it's a black box, it's unknown, it's statistics, blah. As a society, as engineers, we can do better. And Baolin Peng took a step that we can all build on now. And that is why him and his colleagues deserve the first Curious Future Nobel Prize-esque award. I don't think there's any branch of artificial intelligence that's as underfunded and underrecognized as XAI, explainability AI. I think this paper is super important, and it won't be until we solve this problem that I think we can really learn to trust these systems. If we can't explain the logic behind why a system does what it does, how can we ever learn to trust it? How could we ever use it to address something like an ethical consideration with no explainability? What if we want to use it to assign accountability for someone who did something either bad or good? Where would we get the credibility from with no logic? So congratulations, Baolin Peng, here is your award. And if you don't mind hitting that subscribe button, my next goal is to get this YouTube channel to 6,000 subscribers. Smash that subscribe button.